Algebra 2 Trigonometry, Concept 33 Notes, Part 2. We're going to solve triangle ABC given some information. In triangles, capital letters are used to denote the angles and lowercase letters are used to mark the side lengths. Side A is opposite from angle A. Side B is opposite from angle B, and side C is opposite from angle C. When you have a right triangle problem, we let C equal the right angle. So on question A, we're going to construct a triangle. I've already done mine. It's a right triangle. A and B will be my acute angles, and C is my right one. So I've labeled what I've been given, and then I have listed off to the side all the things that I need to find to solve the triangle. Because when you solve a triangle, which our directions say, you find out all the angles and the side lengths. So right away, I can find angle A. I know that that is also going to be 45 degrees. So I do have a special right triangle, but let's go ahead and practice using some of our trig ratios to solve this triangle. So I'm going to go ahead and label angle A, and then I'm going to start by finding length A. So I have the angle 45 degrees. I want to find side A, which is opposite, and then I know side the hypotenuse, which is 5. So I can set up a ratio and say that the sine of 45 degrees equals A over 5. And then I can just multiply both sides by 5. Just do what you need to do to solve. So we'll have 5 times the sine of 45. And then we're rounding to tenths place because that's what our directions say. So it will be 3.5. Now at this point, we're going to work smarter. So since this is a 45, 45, 90 triangle, that means that our side length B will be the same as A. These legs are in a 1-to-1 ratio. So I can go ahead and just put down my side length B.
For problem B, we're going to start by setting up our triangle. So we're going to draw a right triangle, and then we're going to label the two sides that we know. So side A and side B. And now I'm going to personally start by finding side C. You could start by finding either angle A or B, but I'm just going to start with my side. So since this is a right triangle, I know I can use the Pythagorean Theorem. So we have side A squared plus side B squared equals side C squared. Remember, it's always leg squared plus leg squared equals hypotenuse squared. So my two legs were A and B, and my hypotenuse is C. If I solve this problem, I will find my side C. The directions tell us to round to the nearest tenth, so I get 11.7 for side C. Next, I'm going to solve for angle A. For angle A, I'm going to use the two sides I was given, so I'm going to use my opposite side and my adjacent side. 6 is my opposite side, and the 10 is my adjacent side. So the trig function that uses opposite and adjacent is tangent. So I'm going to set up an equation using tangent. So tangent of my angle, so tangent of A, equals my opposite over adjacent. Okay, anytime we're solving for an angle, we're going to set up our equation like this. And then what I need to do is I need to get A alone. And the only way I can do that is by doing the inverse of tangent. So we have tangent of A on the left, and I want to do tangent inverse to move it over to the other side. So I'm going to take tangent inverse of both sides. On the left, I'll just have A left. And on the right, I'm going to have tangent inverse of 6/10. So whenever I say tangent inverse, that's written as tangent with a -1 as a superscript. We've done a lot with inverses. We've done square roots and squares. Those are inverses. We've done adding and subtracting. Those are inverses. Multiplying and dividing, inverses. It just undoes the tangent function I had above. So now we can go to our calculator, and you're going to have a tangent inverse button on your calculator. For me, I have to hit the second button and then the tangent button, and I get tangent inverse. So tangent inverse of 6/10 in my calculator is going to give me 30.9637 and so on. My directions actually don't tell me what to round to for an angle, but we're just going to say to the nearest whole number, nearest whole angle. So 31 degrees is what we have for angle A. Angle B is going to be easy to find because I already know two of my angles. So I can just do 180 minus 90 minus 31, and we get angle B to be 59 degrees.
Now let's talk about angles of elevation. So if you look at a point above you, like the top of a building, the angle that your line of sight makes with the line parallel to the ground is called the angle of elevation. So we'll look at this diagram right here. There are lots of problems that we can solve using that idea of an angle of elevation. When we have an angle of elevation and drop down the distance from the top of our sight line to the horizontal, we have a right triangle. So let's look at A and then let's set up a picture and solve the problem. So a parasailer is attached to a boat with a rope 72 feet long. So here's my boat, and then here is my parasailer. The angle of elevation from the boat to the parasailer is 28 degrees. So if I'm on the boat and I'm looking up, from this horizontal line here, there's my angle of elevation, 28 degrees. Estimate the parasailer's height above the boat. So what we're looking for here is this height. Now the boat is over to the left, but when it's height above the boat, this distance here would be the same as the distance over here from the boat. So we're looking for X, and then I notice that my rope is 72 feet long, so that right there is that length. So I look at what I know and what I want to know. I know the angle, I want to know the side that's opposite, and I know the length that is the hypotenuse. So that would be sine. So I can say the sine of 28 degrees equals X over 72. Multiply both sides by 72, and you'll have the height that that parasailer is above the boat. So approximately 33.8, and we are in feet. All right, let's look at the next problem. So a nursery plants a new tree and attaches a guy wire to help support that tree. So here's the ground, and right here is the stake, and now the wire is going to go up to the top of the tree. And that wire, the 8 is 8 foot, so I'm going to put that measurement of 8. From the stake on the ground, the angle of elevation of the connection with the tree is 42 degrees. So from the stake looking up, that's 42. And then find to the nearest tenth of a foot the height of the connection point to the tree. So that is what we're looking for, and there's our right angle. So once again, we know an angle, we want to know the side that's opposite, and we know the hypotenuse. So we could use a sine function. So the sine of 42 equals X over 8. And then you can just multiply both sides by 8 and find out that that height is about 5 point, if we go to one decimal place, 5.4 feet. You are now to the independent practice problems. So you need to pause the video, work these problems on your own, and then come back and check your answers. Check your work on number 1. Make sure that you found the third side of the right triangle correctly using the Pythagorean Theorem. We're keeping it in exact terms, so it would be the square root of 51. And then look at all of the 6 trig functions. Make sure on the ones that had a radical in the denominator that you rationalize. If you have any questions on these, you can ask during the teacher talk. Check your answer on number 2. I've solved this 2 different ways. So I solved it using special right triangle, just taking that side of 6 and setting it equal to x times the square root of 2, knowing that x would be the length of the legs of the triangle. So in exact terms, we get 3 times the square root of 2. I also set it up using a cosine function. And in that case, I estimate it and I round to tens place, so it would be approximately 4.2. And now for number 3, make sure that you set up your right triangle with C as the 90-degree angle, A and B are the other acute angles, and then the side lengths are those across from them. So I use the sine of 17 to find length of B, which is approximately 3.5, and then the cosine of 17 to find the length of A, as I have them labeled on my triangle. And so your other length of your leg would be approximately 11.5. Now you're ready for the teacher talk over this concept.